You know, I often wonder, what if the night sky is not really a ceiling above us, but a kind of doorway? And if it is a doorway, then perhaps the first question we should dare to ask is this: what exactly are we stepping into when we look toward Andromeda? You see, we tend to imagine it as a distant smudge of light, a quiet island floating far beyond our reach. But well, what if that fragile blur is actually the vastest thing you've ever tried to hold inside your mind? What if the true scale of Andromeda is so immense that our usual sense of distance, of size, of place, simply dissolves the moment we approach it? As I sit here with you, speaking slowly into the soft air of the late hours, I find myself imagining that galaxy not as a number on a chart, but as a presence, a great spiraling continent in the dark, its halo stretching so far, so quietly, that it brushes against our own Milky Way long before the light from its stars ever reaches us. And that's the thing. We think we see the universe because we have photographs, diagrams, neat little orbits drawn on flat paper. But, the truth is gentler and stranger. The cosmos is not a picture. It's a landscape we're moving through, even now, even tonight, in this small corner of 2025. And perhaps the more we learn about Andromeda, the more we learn about our own smallness. Not a belittling smallness, but the kind that invites wonder, the kind that asks, where do we truly stand in all this space? Before we go on, I'd like to ask you to subscribe to the channel and leave a like. My aim here is simple, to help you drift off to sleep while exploring the wonders of science. Where are you on the map? Let me know where you are in the world and what time it is in the comments. It's always fascinating to see who's joining us from all around the world. So let's continue. You see, when we begin to speak about the true size of Andromeda, there is this quiet moment where the mind hesitates, as if standing at the edge of a deep valley and sensing it has no familiar language to measure what it sees. And, that hesitation is quite natural. We are creatures who navigate our days through rooms and streets and cities. Even the Earth itself feels enormous only until we place it beside a star. But a galaxy, well, a galaxy is something else entirely. Andromeda does not simply sit in the sky as a pretty swirl of light. It occupies space the way a mountain range occupies a continent, except stretched across a realm so large that time, rather than distance, becomes our only faithful ruler. We often hear that Andromeda is larger than the Milky Way. That sounds simple enough, almost like comparing two islands on a map. Yet the truth is more layered. The luminous disk, the part we see in photographs, is only the faintest outline, like the crust of a loaf of bread that hides a massive volume inside. The visible disk alone spans more than 200,000 light-years, already wider than the Milky Way as we currently measure it. But that disk is merely the bright skin. Beyond it lies a misty structure that does not glow, a halo woven from dark matter, extending hundreds of thousands of light-years further still. And if you were to glide through that halo, you would not feel a single particle touch you. Yet its gravitational presence would be shaping your path, pulling and guiding with a hand you can never see. And perhaps that is the first truth that shakes our sense of scale. A galaxy does not end where the light fades. The images we have grown accustomed to, flat photographs on screens and pages, trim reality into a neat shape. They carve a crisp boundary around something that in truth has no clean edge at all. In Andromeda, the stars themselves float in a structure that blurs into space like smoke dissolving into the air. If you tried to stand somewhere and declare this is the edge, you would find that gravity continues, extending outward like an echo that refuses to fade. I suppose this is why the comparison with the Milky Way becomes even more striking. Our own galaxy, familiar in name though not in experience, is wrapped in a similar halo, yet Andromeda's is larger and heavier. You can imagine it as two great overlapping clouds drifting toward each other across intergalactic space. The bright spirals are only the cores of those clouds. Their true bulk, their true presence, reaches far beyond anything our eyes can register. And well, that unseen presence is a reminder that reality is often greater than perception, a theme the universe whispers again and again. If we were to place Andromeda closer to Earth, close enough for its real size to impress itself on the sky, the view would be nothing like the soft blur we capture in long exposure photographs. You would lift your head at night and find a vast shape stretching from horizon to horizon, grander than any constellation. Its disk would dominate the heavens, glowing faintly across an expanse dozens of times wider than the moon. The moon, which feels so large and intimate, would shrink to a tiny coin by comparison, almost comical in its smallness beside the galaxy's sweep. You might even forget to breathe for a moment because the night would no longer feel like a ceiling. It would feel like a window into something incomprehensibly wide. And you see, thinking about that scale forces us into uncomfortable but beautiful territory. Light itself becomes a kind of slow traveler, a pilgrim moving through this colossal structure. Imagine a beam of light entering one end of Andromeda and needing more than 200,000 years just to cross the bright region. And then imagine it traveling another 100,000 years or more to exit the outer halo where stars thin into darkness. Light, the fastest thing we know, must labor across these distances. And there is something profoundly humbling in that. It tells us that size, at this level, is not measured in miles or kilometers, not even in the lifetimes of civilizations. It is measured in eras. Inside this enormous frame, the space between stars might appear empty, but emptiness is never the whole story. The galactic structure itself, even in its voids, is part of Andromeda's size. Within its disk, stars orbit like grains of dust in a whirlpool, yet the gaps between them are so large that entire planetary systems could drift through without touching anything. This empty space is not a mistake or a flaw. It is the architecture of a galaxy. The emptiness is part of its shape, part of its magnitude. When astronomers talk about diameter, they are not only mapping solid objects. They are mapping relationships, gravity, density, orbital paths, the long arms of influence that bind a galaxy into being. And, there is also this odd human habit of believing that what we see is all that exists. When we look at images of Andromeda, we assume those luminous spirals represent the real boundary. But what we forget is how images compress reality. A photograph flattens depth into surface. It makes a three-dimensional storm appear like a drawing on a page. The real Andromeda is thick, layered, structured. Its central bulge is not a flat plate, but a swelling sphere of stars. Its spiral arms are not delicate ribbons, but vast regions full of stellar nurseries, shock waves, nebulae, and star clusters scattered like islands in a cosmic sea. Even the dark lanes that cut across those arms are not empty lines, but dense stretches of dust, heavy enough to sculpt patterns in starlight. If you were drifting inside that galaxy, the size of it would not feel like a number written in some textbook. It would feel like a journey. The disk, though thin compared to its width, is still deep enough that a ship traveling from top to bottom would require ages. And through that journey, the stars would change around you, the light shifting from blue to gold, from clusters to expanses of quiet emptiness. You would begin to sense that a galaxy is less like an object and more like a world without ground or sky, without seasons or borders, yet rich with motion and structure. Perhaps the most challenging idea is that Andromeda's true size includes the regions where the density of stars becomes so low that, to human intuition, they cease to feel like part of the galaxy at all. But gravity does not share our intuition. Gravity binds. It maintains coherence across astonishing spans. Even a star wandering hundreds of thousands of light years from the bright disk is still part of the galaxy's anatomy. It belongs to the same vast organism, pulled along by the same unseen tide. And well, when we consider all of this, something curious happens. Our own place becomes smaller, yes, but in a way that invites wonder rather than despair. It makes us aware that even in 2025, with all our technology and photographs and maps, we are still beginners learning to grasp what a galaxy truly is. We live inside one, yet we can hardly imagine the reality of another. Andromeda forces us to stretch our minds, to accept that the universe is not limited by human proportion. I suppose that is why talking about its size becomes a gentle invitation to the next question. If the space Andromeda occupies is so enormous that light itself struggles to cross it, then what of the distance between us and that great spiral neighbor? How do we measure the gulf that lies between two galaxies drifting toward each other across the cosmic dark? And how does that distance reshape the way we think about travel, time, and our fragile sense of nearness and separation? Well, perhaps this is the right moment to step from size into distance, and to let our minds wander a little further into the quiet space that stretches between home and the approaching giant. And so, drifting from the vastness of Andromeda's size, we find ourselves peering into the space that stretches between us and that colossal spiral. And you see, this distance is often stated as if it were a simple figure, a tidy measurement that we can fold into our minds without trouble. 2.5 million light years. People hear it, nod quietly, and suppose they've understood something. But well, that number is a veil. Behind it lies a gulf so profound that even imagination begins to tremble. When we say Andromeda is 2.5 million light years away, we are saying that the light touching our eyes tonight began its journey long before human beings existed. It left those distant stars while Earth was young, while early hominins wandered through landscapes that no longer exist. And the strange part is that this light, traveling at what we call the universe's ultimate speed, still needed millions of years just to cross the void. It reminds us that distance at the galactic scale is not a place we can ever visit with footsteps or even the swift tools of our age. It is a kind of time ocean, and every star we look toward is a boat we see only after it has already sailed far away. And if we were to imagine traveling to Andromeda at the speed of light, that impossible speed that nothing with mass can attain, the journey would still require those same 2.5 million years. Whole continents would shift, species would rise and vanish, and the travelers, if they somehow could exist, would move through epochs rather than miles. It is a humbling thought. Even the fastest thing we know is sluggish when confronted with the architecture of the cosmos. Now suppose we soften the thought experiment. Let us imagine launching a spacecraft using the fastest technologies we have today, technologies as of 2025. A probe moving at tens of thousands of kilometers per hour feels astonishing to us, almost reckless in its swiftness. Yet over cosmic distances, its progress would resemble the crawling of a shadow at dusk. It would take billions of years, longer than Earth has existed, longer than the sun will continue to shine. The Milky Way and Andromeda would collide and merge before that tiny craft had even approached its destination. And there is something gently melancholy in that, but also beautiful, because it shows us how deeply we are rooted in our home galaxy, how far beyond reach the next island truly lies. You know, there is a curious illusion in astronomy that comes from the way we use images. We often look at photographs of galaxies placed side by side, as if they hovered next to each other like objects in a display case. A picture might show the Milky Way on the left and Andromeda on the right, their delicate spirals only a few centimeters apart on the page. But well, that centimeter is a lie, a compression so extreme that language can barely describe it. If 1 pixel in an astronomical image represented the true distance between 2 points, that pixel might stand for thousands or even tens of thousands of light years. Our eyes glance over it casually because a pixel is nothing to us, but in reality, the universe hides a vastness inside every dot of color. And perhaps this is why scaling models become almost humorous. If we were to draw Earth and Andromeda at sizes we could hold in our hands with Earth reduced to a tiny speck, the distance between them would stretch farther than a city, farther than a country, perhaps even farther than many people will travel in their entire lives. A single grain of dust on one end of a continent, and another galaxy-sized grain on the opposite shore. And between them, the emptiness we rarely dare to imagine. If we shrink Earth down to a bacterium, Andromeda becomes a distant glowing island far beyond the bacterium's world, so distant that from its point of view, the galaxy wouldn't exist at all. And the reason this is so difficult to grasp is that human minds evolved for the intimate scales of Earth. We understand the distance to the next room, the next town, even the next planet with a sort of stretched intuition. But the distance to another galaxy is not something our brain is built to handle. It is like asking a candle flame to illuminate an ocean. The numbers exist, yes, but the feeling does not. Our ancestors never needed to imagine millions of light years. Their survival depended on reading footprints in sand, sensing weather in the wind, or recognizing the path home by the shape of a mountain. So perhaps it is no surprise that when we speak of intergalactic space, our minds reach a point where they simply stop, unable to reconcile experience with scale. Yet there is also a tenderness in this limitation. It means that every attempt to understand the gulf between the Milky Way and Andromeda becomes an act of imagination, a stretching of the heart as much as the intellect. When astronomers tell us that this gulf is filled with almost nothing, we picture emptiness. But the emptiness is not a barren desert. It is a subtle, whispering field of gravity, photons, particles, and faint cosmic background. It is the quiet between two great lungs of a cosmic organism, slowly drifting toward one another in an ancient dance. And you see, even this idea that the distance is static is an illusion. Andromeda is not merely sitting out there waiting for us to come to terms with its remoteness. It is moving. The Milky Way is moving. Space itself is shifting beneath our feet in ways we cannot sense. That 2.5 million light-year separation is shrinking, slowly but surely, as gravity draws the two galaxies closer. In the time it takes light to cross the gulf itself has changed. The map is never still. The universe does not hold its breath for us. It is strange, isn't it, to imagine that we are already connected to Andromeda, not just by light, but by fate. The journey between us is impossibly large for any spacecraft, yet the galaxies themselves will traverse it effortlessly, meeting in billions of years, blending like two clouds carried by a soft celestial wind. And once we begin to sense that, the meaning of distance shifts. It becomes something dynamic, something alive. Perhaps the most startling realization is that the feeling of distance we carry is not only inaccurate, it is fundamentally incompatible with the reality of the cosmos. Our intuition treats distance as emptiness, as separation. But between galaxies, distance is history. It is motion. It is the long, unfolding path of gravity sculpting the future of stars. The gulf between us and Andromeda is not a void. It is a story in progress. And when we consider all of this, it leads naturally to a deeper reflection on mass and gravity themselves. What is it about Andromeda that allows it to draw upon the Milky Way from so far away? How can something so distant exert an influence that reaches across millions of light years, shaping the movement of entire galaxies as though they were leaves on a cosmic tide? Well, perhaps now is the moment to shift our attention from distance to weight, from the space between galaxies to the invisible forces that bind them. And to do that, we must look into the true mass of Andromeda, the dark matter that surrounds it, and the quiet gravitational power that shapes the fate of stars. And so, as we drift from the great emptiness between galaxies into the question of why Andromeda pulls on us at all, we step into a realm where weight and influence are no longer earthly things. You see, when we talk about mass on our planet, we mean rocks, mountains, oceans, the tangible heft of matter we can touch or climb or stand upon. But in the cosmos, mass becomes something deeper, something almost invisible in its power. And that is where Andromeda reveals a truth we often overlook. It is not merely large, it is heavy in a way that bends the structure of space itself. Its gravity reaches across the void like a slow and patient hand, shaping the dance of galaxies long before they ever meet. Andromeda outweighs the Milky Way. We say that casually, as though comparing two stones, yet the implications ripple through everything. The stars we see, the glowing spiral arms that catch our attention in photographs, Those are just the glittering surface. Beneath them lies an enormous reservoir of mass that does not shine, does not warm, does not reveal itself through any form of light. It is dark matter, the quiet sculptor of galactic architecture. In Andromeda, this unseen halo is far more massive than the luminous disk. It is hundreds of times larger in volume, enveloping the galaxy like a vast, ghostly sphere extending well beyond the farthest visible star. And well, that is the thing. The true weight of a galaxy is not in what we can see, but in what we cannot. Imagine drifting toward Andromeda. Long before the bright spirals begin to fill your view, before the gold of its central bulge glows against the black, you would already be inside its gravitational influence. You might not feel anything at first. Gravity, after all, whispers rather than shouts, but you would slowly be pulled, steered, guided by a force that originates from matter you cannot see. The dark matter halo is the great anchor of the galaxy, shaping both its internal structure and its relationship with the space around it. Without this halo, Andromeda's spiral arms would not hold their graceful form. They would unravel. Its stars would drift apart. The galaxy would lose its coherence, dissolving into the cosmic sea. Dark matter is the silent skeleton of it all. And perhaps the most astonishing part is how far this influence reaches. The halo extends hundreds of thousands of light years beyond the visible disk. Picture a glowing island of stars, and around it, an invisible ocean of mass so wide that the luminous region seems like a lantern floating inside a vast bubble. And within that bubble, gravity rules. It pulls on stars, on gas, on other galaxies, on entire streams of matter stretching out like threads woven from the remnants of long-dead companions. Andromeda has its own family of smaller galaxies, some torn apart by its pull, others orbiting quietly, their shapes distorted by the deep gravitational well. These satellite galaxies are not just neighbors. They are captives of Andromeda's weight. When astronomers talk about stellar streams, long trails of stars arcing across the dark, they are witnessing history written by gravity. Many of these streams come from smaller galaxies that wandered too close to Andromeda. They were tugged apart, their stars pulled into thin, elegant ribbons that now drift through the halo like strands of cosmic silk. These remnants reveal the hidden structure of the gravitational field, much like dust motes swirling in sunlight, reveal the shape of a breeze. And every one of these streams tells the story of a galaxy that approached the giant and lost its identity to its tremendous mass. What is even more remarkable is how Andromeda's gravity interacts not just with its satellites, but with the Milky Way itself. The dark matter halos of both galaxies have already begun to touch in a subtle way, not with light or with the edges of their visible disks, but through the slow merging of their gravitational fields. Even now, even in 2025, before the galaxies physically collide billions of years from now, their halos are brushing against one another like distant tides. The pull we feel is faint, but real. The future collision is not merely predicted. It is already encoded in the fabric of space because of the mass each galaxy carries. And in that sense, gravity is less a force and more a promise. Andromeda's mass is not only stored in stars and dark matter, of course. Between its spiral arms lies a vast reservoir of interstellar gas and dust. These are the raw ingredients of creation, the material from which new stars will one day ignite. This gas stretches through enormous regions, forming clouds so large that a star system could wander through them for generations. These clouds respond to gravity as well, collapsing slowly into new suns, new worlds, new cycles of life and death. In every direction, Andromeda's mass asserts itself, shaping not only the structure of the galaxy, but its future, where stars will be born, where they will drift, where they will die. The blueprint is written by gravity. It is worth pausing on that thought. Gravity is the great storyteller of the cosmos. It determines how galaxies evolve, how stars cluster, how planets form, and even how time flows. And in Andromeda, gravity is not gentle. It is immense, pervasive, and patient. It is what allows the galaxy to maintain its spiral shape across eons. Each arm is not a static structure, but a wave. Material moves in and out, rising and falling like a tide. And behind the tide lies mass, the quiet dictator. And perhaps as we consider all this, we begin to understand something subtle about the character of a galaxy. A galaxy is not merely a collection of stars, it is a gravitational ecosystem. Every star orbits not because of its own momentum alone, but because the total mass of the galaxy holds it in place. In Andromeda, stars in the outer regions orbit far faster than they should if the galaxy were made only of visible matter. This discrepancy is one of the great clues that revealed dark matter to us in the first place. The galaxy spins too fast to hold itself together, unless there is something more, something heavy, invisible, and abundant. And that unseen mass is not an accessory. It is the dominant component. This immense dark halo also explains why Andromeda's influence reaches across millions of light years. The gravitational handshake between Andromeda and the Milky Way is not performed by stars or gas. It is performed by dark matter. That is why the galaxies are on a collision course. The cosmos is not empty between them. It is filled with the quiet tension of mass working across space. Andromeda is not drifting toward us by chance, but because the structure of matter itself compels the motion. I suppose the most moving part of all this is how humanity fits into the picture. Here we are, in a small star system orbiting a modest galaxy, looking outward at a giant whose mass is so great it bends the path of our own future. And yet, standing on Earth, we feel none of that weight. We move through our days unaware that an entire galaxy tugs faintly on us, shaping the destiny of the Milky Way itself. It is humbling in the softest way, like discovering that the ground beneath your feet is part of a planet you never fully considered. And as we look deeper, we find that mass is tied intimately to possibility. The more massive a galaxy, the more stars it contains, the more systems it hosts, the more chances there are for planets, for atmospheres, for chemistry, for life. Gravity gathers raw material into suns, suns warm the dust around them, and from that warmth, worlds emerge. Andromeda, with its greater mass, likely holds more stars than the Milky Way. And if even a fraction of those stars carry planets, and even a fraction of those planets hold conditions suitable for life, then the galaxy becomes not just a structure of matter, but a vast field of potential. Mass becomes the quiet seed of imagination. And that brings us gently toward the next step in our journey. If Andromeda's weight shapes the paths of stars and galaxies, then surely it also shapes the number of stars it can cradle, the number of worlds it might host, the complexity that might bloom within it. We have considered size and distance and mass. But what about the stars themselves? Scattered like embers across this enormous spiral. What worlds orbit them? What possibilities sleep within their light? Well, perhaps this is the moment to drift from gravity into starlight, and to look not at the forces that bind a galaxy, but at the countless suns that burn quietly within it. And so, as we leave behind the quiet gravity that shapes Andromeda's vast form, it feels natural to drift toward the lights embedded within that gravity, the countless suns scattered across its spiraling arms. You see, when we speak of stars in a galaxy, we often imagine something tidy, a number we can jot down and comprehend. But well, the reality is far larger and far more intricate. Andromeda carries within it more stars than the Milky Way, perhaps 1 trillion of them, each one a small furnace burning through cosmic time, each one with the potential to cradle worlds. And suddenly, the galaxy stops being a distant island and begins to look like a vast archipelago of possibilities, each star a tiny lighthouse in the dark. And you know, when you try to picture 1 trillion stars, the mind falters. We grasp millions, perhaps tens of millions, the way we might imagine grains of sand in a handful. But 1 trillion is something else entirely. It is shoreline after shoreline, desert after desert, stretching further than thought can wander. And embedded in that unimaginable multitude is a simple truth. Every one of those stars could be a sun to someone. Each one could host planets, some barren, some icy, some molten, and some, just some, balanced in that fragile zone where light becomes warmth and warmth becomes chemistry, and chemistry becomes the first trembling possibility of life. Andromeda is not merely a larger version of our galaxy, it is a larger arena for potential. If even 1 in 10 stars held a planet, we would be speaking of hundreds of billions of worlds. If even 1 in a million of those had the right conditions for biology, we would still be dealing with numbers far beyond our capacity to imagine. Life, in such a context, ceases to feel like an accident. It becomes something the universe might try again and again, quietly, patiently, across the dark spans of its spiraling arms. Yet perhaps the most surprising part is that the space between these stars is not empty. The interstellar medium, that thin soup of gas and dust, stretches through Andromeda like a subtle atmosphere between suns. It contains the raw materials of planets, the ashes of ancient stars, the molecules that predate biology itself. A galaxy is not hollow. It is a living ecosystem made of space and light, of void and matter intertwined. When you drift through the dark between stars, you drift through the aftermath of creation itself, and you see, when astronomers say that each star could have its own solar system, the idea is not poetic exaggeration. It is the statistical expectation of a universe that builds worlds as naturally as oceans build waves. Planets form wherever there is enough gas and dust to collapse into a disk around a newborn star. Andromeda, with its vast supply of such material, must be brimming with these silent formations. Some systems may resemble our own, others may be wildly different. There might be worlds entirely covered in oceans, planets encased in ice, planets wrapped in toxic air, planets orbiting so close to their suns that rock melts like wax. Then there are the quiet, hidden systems orbiting the smallest, faintest stars, cool red suns that burn for trillions of years. Around them, planets could circle in stable, gentle orbits long after our own sun has faded into darkness. And somewhere, drifting through the light of an unknown star in Andromeda, life could have found a foothold. Maybe microbial, maybe more. Perhaps it thinks, perhaps it dreams, perhaps it simply exists, unaware of the vast cosmic ocean around it. Or perhaps life has come and gone in cycles we will never witness. And well, that is the thing. When you consider the number of stars, the number of potential worlds, Andromeda stops being a distant object and becomes a vast question, one that echoes back toward us. What if we are not alone in this galaxy? What if intelligence has risen countless times, only to vanish again like ripples on water? What if civilizations have looked toward the Milky Way the way we look toward Andromeda, with wonder, with questions, with hope? 1 trillion stars create 1 trillion chances for mystery. And yet, the stars within Andromeda also tell us something deeper about the galaxy's character. The central bulge is crowded with old stars, ancient suns burning dimly, survivors from the early eras of galactic formation. They whisper of time and endurance, of changes we can scarcely imagine. Farther out, along the spiral arms, the stars grow younger and brighter, forming clusters that sparkle like cosmic seedlings. And among these clusters lie stellar nurseries, enormous clouds where gravity and gas give birth to new stars in slow, luminous waves. The galaxy is not static. It is alive with creation, with cycles of birth and collapse shaping its structure over billions of years. The number of stars also tells us something about energy, about heat, about the flow of radiation through the galaxy. Every star is a source of light, a source of time itself, because light carries information across the void. When we look at Andromeda, we are looking at billions of stories written in photons, and each star, even the faintest, is a character in that story. Sometimes people imagine galaxies as cold, lifeless things, perfect spirals drifting in a vacuum. But when you consider the stars, really consider them, the galaxy becomes a vast and dynamic machine of physics and possibility. It becomes a place where matter constantly rearranges itself into new forms. In this sense, Andromeda is a cradle for worlds. It is heavy enough, rich enough, luminous enough to support billions of different histories, each unfolding quietly across time. And perhaps that is why understanding the star count in Andromeda changes the way we think about life. With so many suns, so many planets, it feels almost improbable that life might be confined to a single world orbiting a single star. And yet, here we are, one small species on one small planet, looking outward with longing and curiosity. There is humility in that, and also wonder. We are the observers of a story far larger than ourselves. But the stars also tell us something else. They trace the motion of the galaxy through space. Each star orbits the galactic center, and together they form the great rotating disk of Andromeda. This rotation is not gentle. It is swift, almost violent by human standards. Stars hurtle around the center in vast arcs, guided by gravity and momentum. Their orbits reveal the mass distribution of the galaxy, and through them we detect the presence of dark matter. The bright stars are like glowing beads strung on invisible threads, and those threads outline the true shape of the galaxy's gravitational field. And as we think about this whirling collection of stars, we realize that the galaxy is not a static painting. It is a dance. Every star is moving. Every orbit is changing. The entire galaxy is swirling through space like a colossal, luminous storm. And yet, despite this motion, there is order. There is structure. The spiral arms persist, not because the stars remain fixed within them, but because waves of density ripple through the disk, gathering stars temporarily before releasing them again. In this cosmic choreography, the stars are both dancers and witnesses. It is this dance that ensures new stars continue to form. As clouds of gas pass through the spiral arms, they compress, collapse, ignite. New suns are born, and once born, they begin to carve out their neighborhoods, shaping the space around them with solar winds, radiation, and gravity. Each star becomes a kind of sculptor, and the galaxy a gallery of their collective work. And perhaps the most enchanting thought is that somewhere in those spiraling arms, solar systems unlike any we can imagine are forming right now. 1 trillion stars mean uncounted possibilities. Perhaps some worlds are destined to remain barren, their skies forever empty. But others, just maybe, hold the potential for oceans, continents, atmospheres, climate cycles, seasons, histories. In that way, Andromeda becomes not just a galaxy, but a reservoir of futures. And you see, thinking about stars naturally leads us toward thinking about motion. These suns are not fixed in place. They drift, whirl, migrate. Some tear through the galaxy at astonishing speeds. Others linger in clusters for billions of years. And when we consider this motion, we begin to grasp that Andromeda itself does not stand still. So perhaps now is the moment to let our attention wander from the glow of its stars to the path the entire galaxy takes through space, to the slow and inevitable approach that will one day bring Andromeda into contact with the Milky Way. And in that approaching motion, we find a new kind of story, not about light or life, but about the great cosmic collisions that shape galaxies across the universe. And so, as we leave behind the quiet shimmer of Andromeda's trillion suns, our attention is gently drawn toward a truth that feels almost paradoxical. Despite its immensity, despite its delicate spiraling arms and the serene beauty captured in telescopes, Andromeda is not still. You see, when we imagine galaxies in the night sky, we tend to picture them as frozen artworks, suspended eternally in darkness. But, well, that is merely the illusion of human timescales. In reality, Andromeda is moving with purpose, drifting through space on a trajectory that will one day carry it directly into the Milky Way, and not in the sense of a collision we might imagine, where objects crash and shatter, but in the slow, graceful merging of two cosmic clouds as vast as imagination itself. Even now, even in this quiet moment of 2025, Andromeda is approaching us at hundreds of kilometers per second. That speed is astonishing, but across the gulf that separates the galaxies, it becomes something subtle, something patient. It is like watching two distant storms inching toward one another on the horizon. If you were to compress billions of years into a single breath, you would see Andromeda rise in our sky like a glowing tide, growing brighter and larger as the two galaxies draw near. But stretched across real time, the approach is imperceptible. Nothing in your daily life shifts. The constellations remain familiar. And yet the future is already set in motion. Andromeda is coming. This inevitability is not an accident. It is the consequence of gravity, the same gravity that shapes stars and planets and the delicate arcs of spiral arms. The Milky Way and Andromeda have been falling toward each other for billions of years, their dark matter halos already interacting, their orbits weaving a slow path toward union. And the idea of galaxies colliding tends to conjure images of destruction, of stars smashing into stars. But that is our Earth-shaped imagination talking. Space within galaxies is overwhelmingly empty. Stars are small, incredibly small, compared with the distances between them. So when two galaxies merge, their stars pass through one another like clouds drifting through clouds. Perhaps the more accurate metaphor is not a collision at all, but a blending. Two immense fogs swirling into one another, exchanging their patterns, reshaping their structures. If you could witness it from afar, sped up millions of times, you would see the two spirals deform, their arms stretching like pulled taffy, their centers drawing closer until they begin to orbit around a shared core. Over time, the tidy spirals unravel, dissolving into a vast, chaotic whirl. The galaxies wrap around each other, folding, twisting, merging. And through it all, the stars within them continue on their paths, guided not by chaos but by the deep currents of gravity. And the most extraordinary truth is that despite this cosmic upheaval, the skies on any inhabited world within either galaxy might not change dramatically in a catastrophic sense. Stars would drift across the sky, perhaps more rapidly than before. Constellations would rewrite themselves, and a glowing, expanding smear, another galaxy, would dominate the heavens for millions of years. But the worlds themselves, the planetary systems, would likely remain intact. The true violence of a galactic merger lies not in the collision of stars, but in the collision of gravitational fields. Entire trajectories shift, stellar nurseries ignite, regions of star formation burst into new life as gas clouds crash and compress. A galaxy merger is both an ending and a beginning, a cosmic storm that seeds creation. Somewhere within Andromeda right now, stars are moving in ways that will one day guide them into the future merged galaxy. What astronomers predict may become a giant elliptical system, sometimes imagined under the name Milkdromeda. That imagined future galaxy will hold within it the combined histories of both systems, each star carrying the memory of its original home like a faint cosmic accent. You can almost imagine future astronomers, billions of years from now, trying to trace which cluster belonged to which ancestral galaxy, much as archaeologists today sift through layers of sediment to understand ancient Earth. Andromeda's motion toward us is not just linear, it is multidimensional. The galaxy does not simply travel like an arrow shot across the void. It drifts, its plane tilted relative to ours, its stars rotating, its own gravitational tides shaping the path it takes. When the galaxies finally meet, the encounter will not be two disks slamming together, but two dynamic, three-dimensional structures interacting in intricate patterns. This is why a galaxy merger resembles the swirling of smoke. There is depth, motion, turbulence, quiet, and structure all at once. And perhaps what moves me most about this slow approach is the perspective it offers. The Milky Way and Andromeda are not separate, isolated universes unto themselves. They are companions in a cosmic dance, drawn together by the invisible threads of dark matter. And through this attraction, we glimpse something universal. Nothing in the cosmos is static. Even the grandest structures move, evolve, transform. And we, on our small blue world, drifting around an unremarkable star, are part of that motion whether we feel it or not. You know, galaxy mergers are among the great sculptors of cosmic history. The largest galaxies we see today, the giants that dominate clusters, were shaped through countless such mergers. Andromeda's approach toward the Milky Way is not an anomaly. It is the natural rhythm of the universe on grand scales. Over billions of years, this slow choreography builds complexity, reshapes systems, and births new generations of stars. When Andromeda merges with us, regions of intense star formation may light up like cosmic fireworks. Entire clouds of hydrogen will collapse under the shock of gravitational compression, forming clusters of young, brilliant stars. And in other regions, star formation will fade, leaving ancient populations drifting quietly in the merged galaxy's halo. Yet as profound as these changes are, they unfold over such vast timescales that no civilization could witness the entire event from beginning to end. A galaxy merger is a story written in billions of years. Life, even long-lived civilizations, would experience only fragments, perhaps seeing Andromeda grow larger in the sky, perhaps witnessing a few structural shifts in their stellar neighborhood. But the full arc is something no single consciousness can hold. This fragility of perspective, this incompleteness, is part of what makes the cosmos feel at once humbling and magnificent. And maybe, if we imagine ourselves standing beneath a night sky millions of years from now, we might see Andromeda as a blazing swirl overhead. Its bright core would dominate the darkness, larger than any moon, its spiral arms faint but vast. The Milky Way's own structure would distort, warp, fold. The two galaxies would begin to overlap, their stars mingling like grains of sand lifted by converging tides. Astronomers of that far future might watch with both awe and resignation, knowing they are witnessing the beginning of a transformation far larger than themselves. But the merger is not an ending. It is a transition. When two galaxies blend, they form something new, something larger, something shaped by the history of both. And that new galaxy carries within it the memory of collision, a memory written in the motions of stars, in the angles of tidal streams, in the shapes of surviving clusters. It is a kind of cosmic genealogy. And this, I suppose, leads us toward the next question in our unfolding journey. If Andromeda's movement across the heavens would reshape the night sky of distant future Earth, then what would Andromeda look like to us now if our eyes were capable of seeing its true extent? What would the night sky reveal if our vision were not limited by the faintness of starlight, if we could truly perceive the full breadth of that approaching giant? Well, perhaps it is time to look upward once more, not toward the future sky of a merged galaxy, but toward the present sky above us, a sky in which Andromeda glows quietly, far larger than the small hazy patch our eyes can detect. And so, standing beneath that imagined future sky where Andromeda swells into a magnificent whirl above us, we cannot help but wonder what the galaxy truly looks like right now, in this quiet moment of 2025, if only our eyes were less limited. You see, for most of us, Andromeda appears as nothing more than a faint smudge suspended above the horizon on a crisp, dark night, a misty almond shape, barely perceptible, often overlooked. It feels small, almost delicate, as though it were just another distant blur among countless others. But well, that impression is an illusion crafted by biology rather than astronomy. If we could truly see Andromeda for what it is, if our vision were attuned to the softest traces of light, the night sky would be utterly transformed. The human eye is a remarkable tool, but it is tuned for survival on Earth, not for deciphering the cosmos. Our retinas are exquisitely sensitive to contrast and motion, to the warm glow of firelight, to the subtle shapes of predators in the dark. But the diffuse, faint light of distant galaxies does not stir them easily. Andromeda, for all its brilliance, spreads its light across such a vast region of sky that its surface brightness falls below what our naked eyes can truly appreciate. It is not that Andromeda is dim. It is that we are blind to the kind of light it offers. If our eyes worked like long exposure cameras, gathering photons patiently over minutes or hours, the entire shape of the galaxy would reveal itself in breathtaking clarity. You would look up and see a disk stretching wider than 6 full moons. Its spiral arms would unfurl across the heavens like glowing rivers of starlight. The bright core would shimmer like a lantern suspended in eternal night. The darkness around it would be traced with faint threads of dust, nebulae, and star clusters. And each night, as Earth turned, that immense structure would drift slowly across the sky, reminding you that you live beside one of the great giants of the local group. But our vision resets every fraction of a second, discarding faint photons before they can accumulate into a coherent image. And so the galaxy shrinks, collapses into a small, washed-out smudge. The grand becomes miniature. The colossal becomes subtle. Our eyes create a simplified version of cosmic reality, a minimalistic sketch of a masterpiece. And in a way, that simplification is almost poetic. It means that the universe hides its largest truths in plain sight, waiting patiently for the rare minds who choose to search for them. The reasons we cannot see Andromeda's full shape come down to 2 main limitations: the faintness of its surface brightness and the filtering properties of our own biology. The galaxy is enormous, truly enormous, but its light is spread so thinly across the sky that each small region shines only faintly. Even the brightest part of Andromeda, the core, is only barely above naked eye visibility under perfect conditions. Everything beyond that fades into thresholds too subtle for human perception. This is why photographs of Andromeda, taken with telescopes and cameras capable of collecting light over long durations, appear so dramatically different from what we see. In a photograph, the galaxy bursts with detail, stretching elegantly across blackness. In our view, it reduces to a whisper. And it makes you wonder, doesn't it? How much of the universe passes unnoticed simply because our senses evolved for a completely different purpose. We navigate forests, not galaxies. We scan fields, not star clusters. And in that sense, our limited vision is not a flaw. It is a reflection of our origins. But it also means that reality, the true reality of the cosmos, is far richer than our eyes allow. Imagine, just for a moment, that humans were born with eyes capable of detecting fainter light. Instead of a handful of constellations and a sprinkling of bright stars, our sky would bloom with structure. Andromeda would not be a rare discovery for amateur astronomers. It would be a nightly companion. Children would grow up under a sky dominated by a colossal spiral, and perhaps their understanding of scale, of place, of existence would be entirely different. They would not think of Earth as the center of anything. They would know from the beginning that we live in the outskirts of something vast. And perhaps that is one of the gentle tragedies of our vision. The night sky is only a compressed version of the true universe. It is like looking at a mountain range through a keyhole. What we see is real, but incomplete. The faint galaxy overhead is not a distant smudge. It is a continent of stars, too large for our senses to grasp. Andromeda is not small. We are simply undersized observers. But even with our limitations, there are ways to coax more from the sky. Under pristine, moonless conditions far from city lights, Andromeda becomes easier to detect. It stretches a little wider. Its shape becomes a little more pronounced. Still, even then, it is only a hint of what is truly there. The galaxy's halo, the vast, ethereal glow surrounding the visible disk, is entirely invisible to the naked eye. It spans far beyond what photographs typically show, enveloping the galaxy in a nearly imperceptible sphere of faint light and dark matter. Its expanse is enormous, dwarfing the moon, dwarfing even our imagination, yet it remains unseen. And you see, in a way, the night sky we know is a kind of edited version of reality. Our eyes curate it, simplify it, making choices about what to reveal and what to hide. But the universe is not edited. It is sprawling, chaotic, layered, overflowing with detail. Standing beneath the stars, we often think we are looking at the whole picture. But the truth is, we are only glimpsing the brightest strokes of a much larger canvas. If we lived on a world orbiting a star much closer to Andromeda, or if Andromeda itself were somehow brighter, our mythology, our philosophy, even our science might have evolved differently. A galaxy dominating the sky would make humanity feel small in a different way. More connected, perhaps, more aware of our place in a cosmic network. Instead of wondering whether galaxies exist, we would live beneath their glow. Instead of discovering the universe through telescopes, we would grow up immersed in it. And there is something deeply moving about that idea. The universe does not change, but our ability to perceive it does. And every improvement, every telescope, every spectral instrument, every photograph, peels back another layer of the cosmos, revealing that what we thought was empty is full, what we thought was small is vast, and what we thought was static is alive. But perhaps the greatest revelation is this. Even though our eyes fail to perceive Andromeda's majesty, the galaxy still shapes our night. The faint patch we see is merely the brightest part of a structure far larger than any constellation. If we could trace the true boundary of Andromeda in the sky, we would find it stretching across enormous swaths of darkness, overlapping familiar star patterns, altering the sky's geometry. The constellations we know would be dwarfed by the sheer scale of a real galaxy laid bare. And that leads us, gently and inevitably, to wonder. If we could peel back the limits of sight not only for Andromeda, but for the Milky Way itself, what hidden structures would surround us? What layers of our own galaxy remain unseen, concealed by brightness, dust, distance? What superstructures lie within the spiraling arms, the central bulge, the thick disk? Well, perhaps now is the right moment to turn our gaze inward, to journey deeper into Andromeda's own anatomy, and to explore the vast internal architecture that photographs only hint at, structures so immense and intricate that they reshape our understanding not just of one galaxy, but of what galaxies truly are. And so, as our eyes adjust to the notion that Andromeda's true form on the night sky is far grander than the pale smudge we know, a new curiosity begins to take shape. If even the visible face of the galaxy hides so much from us, then what of its inner landscape? What lies within those luminous arms, those hazy contours, those depths that photographs capture only as faint gradients? You see, a galaxy is not a flat picture. It is a three-dimensional world, layered and textured and alive with structures so vast and intricate that, well, comparing them to anything on Earth feels almost laughably inadequate. Andromeda, in particular, is a place of staggering internal architecture. The spiral arms we admire from afar are not delicate, wispy filaments. They are colossal highways of stars, gas, and dust stretching across tens of thousands of light years. If you could drift inside one, it would feel less like entering a glowing ribbon and more like entering a continent, a sprawling region filled with clusters, nebulae, shock fronts, star-forming clouds, and older stellar populations moving in slow, complex orbits. The arms are not static things. They are density waves like patterns on water, and stars migrate through them the way leaves drift through an ocean. Their shape is the result of gravitational interactions, waves of compression that sweep through the galactic disk again and again. And when we look at images of Andromeda, we often see only two main spiral arms, each sweeping gracefully outward from the central bulge. But in truth, the galaxy's structure is far messier, richer, and more layered. Multiple arm segments branch, merge, twist, and fade. Some arms loop back into the disk, others dissolve into clusters and dust lanes. These substructures give Andromeda a kind of fractal texture, patterns repeating at different scales, hints of past interactions with satellite galaxies, ripples from ancient collisions, and scars left behind by gravitational tides. And at the heart of the galaxy lies something extraordinary, a dense, blazing central bulge filled with old stars. This bulge is not a gentle swelling. It is a tightly packed region where hundreds of millions of stars crowd together in a sphere just a few thousand light years across. If you lived inside such a region, the night sky would never be dark. Dozens of bright stars would outshine even our full moon, and the Milky Way, if you could still see it, would pale behind the glow of your own surroundings. The central bulge is hot, turbulent, and ancient. It holds clues to Andromeda's formation, memories of the galaxy's early years when stars were forming rapidly and gravitational interactions sculpted the disk. And deeper still, hidden beneath layers of swirling starlight, lies the supermassive black hole at Andromeda's core. Though not as active as some black holes in more tumultuous galaxies, it still holds millions of solar masses, an anchor around which the entire galaxy orbits. And surrounding all of this is the disk itself, thin but enormous, stretching more than 200,000 light-years across. The disk is not uniform. It contains ridges of dust that obscure starlight, cavities left by supernova explosions, rings of gas triggered by ancient collisions, and enormous star-forming regions, vast nurseries where hydrogen clouds slowly collapse to ignite new suns. These regions can span hundreds of light years, glowing in soft hues from the radiation of young, intense stars. If we could fly through one, it would feel like drifting through a cosmic vineyard, each glowing tendril a cradle for future worlds. The biggest of these star-forming complexes in Andromeda rivals or surpasses anything in the Milky Way. There are clouds so massive that they carry the mass of millions of suns, swirling and collapsing under their own gravity. Within them, protostars ignite like embers scattered across a dark field. Some regions birth entire clusters, hundreds or thousands of stars forming nearly simultaneously, like a firework blooming in slow motion across a million years. And well, the deeper we look, the more we realize that these structures are not isolated. The galaxy is threaded with superstructures, rings, ripples, and faint arcs that betray the gravitational influence of long-forgotten encounters. Some astronomers believe that Andromeda once absorbed smaller galaxies, their remnants stretching into faint streams that wrap around the disk. These streams can span hundreds of thousands of light years, invisible to the naked eye but detectable in sensitive images, like ghostly fingerprints of past cosmic events. Inside the disk, the distribution of stars varies dramatically. The inner regions are hotter, denser, and older. The outer arms are cooler, more diffuse, filled with younger stars and active star-forming regions. And beyond even these lies a subtle warp in the disk, a bending caused by gravitational interactions, perhaps with satellites or with the Milky Way itself. This warp gives Andromeda a slightly twisted appearance in 3 dimensions, a reminder that galaxies are not rigid structures, but flexible, dynamic systems responding to every tug and tide around them. And you see, the dust lanes are among the most beautiful features. They stretch across the disk like dark rivers, absorbing light and creating contrast against the bright stars behind them. These lanes are dense, cold, and fertile, the places where future stars and planets will eventually emerge. In many ways, the dust lanes are the wombs of the galaxy. Without them, star formation would halt, and Andromeda would slowly fade as its existing stars aged and died. But beyond the bright disk lies something even more subtle: the halo. Though we often think of halos as empty or diffuse, Andromeda's halo is rich with structure. It contains ancient star clusters, some older than the galaxy itself, relics from the early universe. These clusters drift through the halo like isolated villages around a sprawling metropolis, bound by gravity but separated by great distances. Some clusters are the remains of cannibalized dwarf galaxies, their stars now stretched into faint tidal streams. And scattered throughout the halo are outflows of gas, debris from past interactions, and the ever-present dark matter that shapes the entire galaxy. One of the most humbling truths is that the halo extends much farther than the visible disk, perhaps more than 1 million light-years from edge to edge. And within that halo, the density of stars and matter may be low, but the structure is profound. Knowing this, we begin to sense that Andromeda is not just a spiral disk. It is a layered system, a cosmic onion of structures nested within structures, each one telling a chapter of the galaxy's billion-year story. But perhaps the most awe-inspiring aspect of Andromeda's internal landscape is how interconnected everything is. The spiral arms are shaped by density waves. The density waves are shaped by gravity. Gravity is shaped by mass. Mass is distributed into stars, gas, dark matter, and remnants of past collisions. Everything is linked. A star born in a quiet region of the disk may still feel the echo of a collision that happened billions of years earlier. A dust cloud forming a new cluster today may be guided into place by ancient ripples frozen into the structure of the galactic disk. And the stars themselves, though scattered across vast distances, move in patterns that collectively define the galaxy's identity. Once you begin to see a galaxy not as a flat picture but as an intricate three-dimensional sculpture, the universe becomes something richer, something deeper. It makes Earth feel small, but in a way that is strangely comforting, because it reminds us that we are part of something far larger than we can ever fully grasp. And as we wander deeper into this inner world of arms and bulges and halos, another question arises. If Andromeda itself is surrounded by such internal diversity, what of the smaller galaxies that orbit it? What of the dwarf companions, the stellar streams, the shredded remnants of ancient mergers? What stories do they tell about the galaxy's past, and how do they shape its present? Well, perhaps now is the right moment to drift outward again, beyond the spiral arms and into the outskirts where Andromeda's satellites circle quietly. Tiny galaxies bound to a giant, each one a chapter in the vast unfolding narrative of the local group. And so, drifting outward from the great spiraling body of Andromeda, past its dense core and the layered currents of its galactic disk, we begin to sense something subtle tugging at the edges of imagination. You see, a galaxy is never truly alone. It is not an isolated island shining in the void. It is more like a sovereign state surrounded by smaller kingdoms, each orbiting, interacting, sometimes merging, sometimes dissolving under its influence. And Andromeda, being the giant that it is, carries with it a retinue of satellites, dozens of small companion galaxies that dance around it in quiet, ancient orbits. They form, in a way, a planetary system writ large, except instead of moons circling a planet, these are entire galaxies circling a titan. And well, when we look at these companions, M32, M110, NGC 147, NGC 185, and many fainter dwarfs, we begin to understand that Andromeda is not simply a galaxy. It is a hierarchy of structures, a cosmic family. Each satellite is a witness to Andromeda's history. Some have lived in its orbit for billions of years, gently shaped by its gravity. Others ventured too close, and their fate became more tragic. They were torn apart, their stars stretched into long, delicate streams that now swirl through the halo like remnants of forgotten rivers. Take M32, for example, a small elliptical galaxy that orbits close to Andromeda's disk. You can almost imagine the tidal tugging it experiences, gravity pulling at it from all sides, compressing it, reshaping it. Some astronomers believe M32 may once have been much larger, perhaps even possessing spiral arms of its own, until Andromeda's immense gravitational pull stripped them away, leaving behind the compact remnant we see today. It is a reminder that galaxies evolve not just from their internal processes, but from their relationships with the systems around them. And then there is M110, another dwarf elliptical, drifting like a quiet companion on Andromeda's outskirts. Though smaller and fainter, it too is sculpted by the gravitational tides that ripple outward from the main galaxy. These elliptical dwarfs might appear featureless at first glance, but they hold histories of disrupted star formation, of gas stripped away, of stellar populations altered by their proximity to the giant. They are survivors, shaped by the cosmic currents that flow around Andromeda. But perhaps the most astonishing features of Andromeda's satellite system are the stellar streams, long, ghostly trails of stars that stretch across hundreds of thousands of light years. These streams are not random. They are the shredded remains of galaxies that ventured too close and were pulled apart by tidal forces. The stars that once formed a coherent system were scattered into thin filaments, each filament preserving the memory of the orbit the dwarf galaxy once followed. These streams wind through the halo like the remnants of ancient paths, fossil evidence of mergers that shaped Andromeda's present form. When we look at these streams, we are not just seeing debris. We are witnessing the quiet consumption that builds galaxies. Andromeda, like all large galaxies, grows by absorbing smaller companions. These mergers feed its halo, expand its disk, and sometimes even trigger bursts of star formation. Each satellite is not merely an orbiting body, it is a potential ingredient in Andromeda's future. And the galaxy we see today carries the imprint of countless such interactions. Yet not all companions are doomed. Many dwarf galaxies orbit safely, maintaining their structure for billions of years. They move like tiny moons in a gravitational ballet, tracing paths that reflect the contours of Andromeda's massive dark matter halo. They are scattered unevenly, some clustered in groups, others tracing unusual orbital planes, hinting at past events that disrupted their distribution. Perhaps they once belonged to a larger group of dwarfs that fell into Andromeda together. Perhaps they formed in the early universe as fragments of primordial matter. Their motions whisper stories we are only beginning to decode. And you see, this is where the analogy to planetary systems becomes profound. Just as planets orbit a star and moons orbit planets, galaxies often orbit larger galaxies. The structure repeats at different scales, like a cosmic rhyme. Andromeda's satellites, some bright and compact, others faint and diffuse, serve as markers for the galaxy's gravitational reach. They define the boundary of its influence. They show us how far Andromeda's invisible hand extends into the darkness. And in that darkness, something even more remarkable unfolds. Many of the satellites are actively being torn apart. Their stars trail behind them like smoke pulled from a drifting ember. Some of these trails extend for hundreds of thousands of light years, forming arcs and loops far from the disk. These tidal streams reveal the shape of Andromeda's halo, much like iron filings reveal the magnetic field around a magnet. The galaxy's structure becomes visible not through its own light, but through the paths of the objects it disrupts. Imagine for a moment drifting along one of these stellar streams. The stars would be sparse, stretched thin, like the faintest trace of glitter scattered across the dark. Each star would carry the velocity of its former galaxy, moving in gentle curves that only gravity can choreograph. The stream itself would be old, perhaps billions of years old, yet still coherent enough to tell the story of its origin. And some of these satellites cling to Andromeda, more like fragile petals caught in a whirl of wind than like stable moons. The faintest dwarf galaxies are barely held together, their stars bound by tenuous gravity. A close pass near the main disk could be enough to unravel them entirely. Their fates are precarious, written in the delicate balance between their internal mass and the tidal forces tugging at them from afar. What is even more astonishing is the number of these dwarfs. There are dozens we know of, and likely many more we have yet to detect. The faintest dwarfs are nearly invisible, dim clouds of ancient stars with hardly any gas left to fuel new births. They are fossils of the early universe, relics older than many stars in the main galaxy. They orbit Andromeda like old companions, silent and unassuming, yet carrying within them the memories of cosmic epochs long past. And well, this sense of nested structures, satellites around a galaxy, streams within a halo, clusters within streams, reminds us that galaxies grow through layers of inheritance. Andromeda's current shape, its spiral arms, its thick disk, its extended halo, all of these are the result of billions of years of consuming, shaping, and guiding smaller systems. The satellite galaxies are not merely external decorations, they are part of Andromeda's identity. If we step back and observe the entire scene from afar, the picture becomes even more mesmerizing. Andromeda is not simply a spiral galaxy, it is a gravitational empire. Its satellites orbit in wide, looping paths. Some form planar alignments, hinting at coordinated infall events. Others drift chaotically, scattered across the halo like sparks from a cosmic forge. And all the while, Andromeda continues its own journey through intergalactic space, pulling its retinue of companions along with it. But perhaps what makes this system most beautiful is how it echoes the structure of our own Milky Way. We too have satellite galaxies. We too have tidal streams. We too are part of a larger gravitational landscape. Andromeda's satellites remind us that the universe is hierarchical, patterned, and interconnected across vast scales. As we drift deeper into this understanding, another question rises gently into view. If Andromeda's satellites reveal the reach of its gravity, then how far does that reach truly extend? What lies beyond the faintest dwarfs, beyond the tidal streams, beyond even the farthest outflow of stars? Well, perhaps now is the right moment to follow that gravitational thread outward, to explore the invisible realm where Andromeda's influence lingers in the dark, shaping space across millions of light years, a region not marked by starlight, but by the quiet, persistent pull of its dark matter halo. And so, as we drift outward from Andromeda's satellite families and the shimmering trails of their disrupted orbits, we begin to sense that we are approaching a boundary that is not really a boundary at all. You see, a galaxy does not end where the light ends. The visible disk, the glowing arms, even the faint halo traced by star clusters, these are only the brightest threads in a far larger tapestry. The true edge of Andromeda is not something you can point to in a photograph. It is something you feel through the mathematics of motion, through the slow drifting of satellites, through the subtle bending of trajectories that tells us an invisible mass surrounds everything. And well, this is where we step into the realm of Andromeda's gravitational influence, an unseen kingdom extending millions of light years across, reaching quietly and persistently into the darkness. And when astronomers speak of Andromeda's dark matter halo, they are not merely adding an invisible shell around the galaxy for convenience. They are describing a structure far larger than the luminous disk, a structure so vast that if you replaced all of Andromeda's stars with a single bright light, the halo would still stretch beyond it like a colossal, transparent sphere. This halo is made not of stars or gas, but of something we cannot see, particles that neither emit nor reflect light, yet exert gravity with immense authority. Dark matter shapes the way Andromeda rotates, holds the spiral arms together, and anchors the satellite galaxies in their long, slow orbits. Imagine drifting outward from the edge of the visible disk. At first, the stars thin. The dust lanes fade. The bright clusters become sparse. But the gravitational pull does not fade with them. Instead, it continues, steady as ever, as though an invisible ocean surrounds the galaxy. The pull remains strong long after the last visible star has been left far behind, and as you continue outward, the gravitational signature begins to feel almost paradoxical. The force persists even where the light does not. This is because the halo extends for hundreds of thousands, perhaps even millions of light years, far beyond the reach of images or telescopes designed to capture starlight. And well, there is something hauntingly beautiful about this idea. The most dominant part of a galaxy is the part we cannot see. If we could somehow illuminate dark matter, give it color, give it glow, the sky would fill not with pinpoints of stars, but with immense, soft spheres surrounding every galaxy. Andromeda's sphere would overlap with the sphere of the Milky Way. They would touch, blending delicately in a region of space where the influence of one galaxy fades into the influence of another. This overlap is not speculative, it is real. Even now, the halos of Andromeda and the Milky Way are brushing against each other gravitationally, long before the visible galaxies meet. And in that sense, the first stage of the cosmic collision has already begun. You see, galaxies are more like gravitational territories than luminous islands. Their halos define their domains. Where halos meet, their fates intertwine. The fact that Andromeda's halo reaches so far that it touches the halo of the Milky Way means that the two largest galaxies of the local group are not separate realms, but participants in a shared gravitational system. They have been linked for billions of years, their futures intertwined like two rivers gradually bending toward confluence. And this halo is not uniform. It is lumpy, textured, responding to the presence of satellite galaxies, to the remnants of past mergers, to the filaments of dark matter that thread the cosmos at large. The satellites orbiting Andromeda trace out the shape of this halo in the same way that planets trace the gravitational shape of the solar system. Their orbits become probes, revealing where the mass lies, how it flows, how it stretches into space. Some satellites move swiftly because they are deep within the gravitational well. Others drift slowly on distant, looping paths, barely clinging to the edge of Andromeda's influence. Through them, we map the invisible. But perhaps the most striking truth is this: Andromeda's influence reaches so far that even intergalactic space, seemingly empty and quiet, is shaped by it. When we imagine the space between galaxies, we often think of emptiness, nothingness. But space is never truly empty. It is full of faint particles, cosmic background radiation, and the large-scale structure of dark matter. And in this environment, gravity becomes a sculptor that works patiently across cosmic time. Andromeda's pull shapes the motion of matter millions of light years away. It draws in streams of gas, guides the trajectories of wandering stars, and subtly alters the orbits of galaxies that come too close. Even the local group itself, the cluster of galaxies that includes both Andromeda and the Milky Way, is governed in part by the mass of Andromeda's dark halo. This invisible influence challenges our notions of boundaries. Where does a galaxy truly end? Not at its disk, not at its last star, not even at the faintest stellar stream. A galaxy ends where its gravity becomes indistinguishable from the gravity of the structures around it. In Andromeda's case, that boundary may be millions of light years from the bright center, perhaps halfway to the Milky Way, perhaps even farther. It is a boundary defined not by light, but by influence. And that influence is profound. When a small galaxy approaches Andromeda, even before it crosses into the luminous disk, its orbit begins to distort. The halo reaches out like a gentle but insistent tide, pulling the dwarf into its sphere. Gas is stripped first, then stars, then structure. Over time, the dwarf may become a stream, and if the stream persists long enough, its stars may scatter into the halo itself, becoming part of Andromeda's extended body. In this way, the halo grows. It is, in a sense, the galaxy's memory, containing the remnants of everything it has consumed. This is why the halo is so important. It is the archive of the galaxy's past, the blueprint of its gravitational present, and the stage for its future interactions. Without the halo, the galaxy would unravel. Without the halo, there would be no spiral arms, no satellite system, no coherent structure. The halo is the unseen architecture that allows Andromeda to exist as it does. But perhaps the most awe-inspiring part of this story is how the halo reveals the interconnectedness of galaxies. Andromeda is not simply a single object. It is part of a network, a cosmic web where halos overlap, merge, influence, and reshape each other across billions of years. The boundary between one galaxy's domain and another's is fluid, shifting, determined by mass and motion rather than light. And as we consider this invisible architecture, another question emerges naturally from the darkness. If Andromeda's halo is vast and powerful, and if its influence extends so far into the local group, then how does Andromeda compare to even larger galaxies beyond? What place does it occupy in the greater hierarchy of the universe? Is it a giant among giants, or merely one among countless others that dwarf it in ways our senses cannot grasp? Well, perhaps now is the right moment to lift our gaze from the quiet halo surrounding Andromeda and look outward again, to the immense cosmic landscape where galaxies gather into clusters, where supergiants loom, and where Andromeda's true scale is measured not by the stars it holds, but by the giants it stands beside. And so, as we drift beyond the invisible borders of Andromeda's vast gravitational dominion, carried along by its silent, sprawling halo, a new question starts to shimmer at the edge of awareness. You see, once we understand how large Andromeda appears when we measure it against the Milky Way, and once we understand how far its influence reaches into the intergalactic dark, something curious happens. We begin to wonder, in the grander hierarchy of the universe, where does Andromeda actually stand? Is it a giant among giants? Or does its scale dissolve into insignificance when set beside the true titans of the cosmos? And well, that question pulls us outward, farther still, into a realm where galaxies gather like clusters of fireflies drifting through cosmic night. And one of the first surprising truths we encounter is that Andromeda, impressive as it is not the largest type of galaxy. It is a grand spiral, yes, one of the largest in the local group. But beyond our neighborhood, the universe builds galaxies of staggering proportions. There are elliptical giants, weighing trillions of solar masses, their diameters stretching far beyond even Andromeda's majestic disk. These galaxies do not possess delicate spiral arms. Instead, they appear as enormous glowing spheres filled with endless populations of old stars, like vast celestial cities shrouded in golden haze. Imagine a galaxy like IC 1101, an elliptical supergiant at the heart of a massive cluster. If Andromeda were placed beside it, Andromeda would seem like a modest island next to an entire continent. The scale difference is astounding. Andromeda's 100 billion or so stars suddenly feel small when compared to galaxies that may contain 10 trillion or more. If you tried to stretch your imagination to hold that much starlight, you'd feel your thoughts slipping, the numbers dissolving into abstraction. These elliptical giants are cosmic monarchs, built not through peaceful formation, but through the repeated mergers of countless galaxies across billions of years. Andromeda, though large and luminous, is still shaped by the more delicate physics of spiral structure. Spirals by nature are younger, more dynamic, and more actively forming stars. Elliptical giants, by contrast, are often older, quieter, monuments of accumulated history. Their mass, their luminosity, their gravitational authority all surpass even the combined weight of Andromeda and the Milky Way. And yet, on our tiny planet, we often speak of Andromeda as if it were the measure of cosmic scale. But well, the truth is more layered. Size is not only measured by diameter or star count. There are also galaxy clusters, immense gatherings of hundreds or thousands of galaxies bound together by gravity. In such clusters, Andromeda itself becomes merely one shimmering bead in a vast necklace of cosmic matter. Even the local group, our small galactic neighborhood, is dwarfed by colossal clusters like Virgo or Coma. If Andromeda found itself inside one of those dense environments, its significance would shift. It would no longer be the dominant gravitational power of its region. It would be one galaxy among many. Brilliant, yes, but far from the center of mass. And you see, this perspective is humbling. When we look from Earth, Andromeda feels monumental, almost overwhelming. It is the closest spiral galaxy, our eventual dance partner in the far future, a cosmic twin to the Milky Way's grandeur. But zoom out far enough, and the grandeur softens. Out there, the universe constructs structures of overwhelming scale, walls of galaxies, filaments stretching millions of light years, voids so vast that all of Andromeda could vanish inside without touching the edges. These superstructures make even giant galaxies feel like dust swirling in an immeasurable wind. And yet, despite all this humbling comparison, Andromeda remains extraordinary in another sense. It reminds us that humanity's place in the cosmic hierarchy is not defined by the largest scales. We do not live in a supergiant elliptical galaxy, nor in the heart of a massive cluster. We live in a spiral galaxy orbiting within a modest group of galaxies, and Andromeda stands as the largest member of that group. It shapes our future and our gravitational destiny in ways no distant cluster could. Its scale influences the evolution of the Milky Way, the orbits of our satellites, and the ultimate form of the merged galaxy we will one day inhabit. So perhaps the better question is not whether Andromeda is the largest galaxy in the universe, but what it means for us. What does it mean to inhabit a region shaped by a spiral giant? What does it mean to exist within the gravitational interplay between two great disks of stars? What does it mean that our cosmic future is tied not to some distant colossus, but to this specific neighbor glowing quietly in our sky? In that sense, Andromeda becomes more than just a point of comparison. It becomes a kind of anchor, one that gives us a sense of scale, identity, and narrative. Even if Andromeda is not the largest galaxy in the cosmos, it is the one we will eventually share a future with. Its mass, its stars, its halo, its motion. All of these shape the environment of the local group in ways that define our cosmic story. And still, despite its significance, we must remind ourselves that our human perspective tends to shrink and flatten the universe. We take images of galaxies, compress them into two-dimensional icons, and imagine them as manageable, almost decorative objects. But galaxies are not simple symbols. They are vast ecosystems that extend beyond intuition's reach. Andromeda is one such ecosystem, but it exists within a cosmic hierarchy far beyond what our senses can easily grasp. And perhaps this is where another question softly emerges, like a flicker at the edge of perception. If Andromeda's true scale is hidden by our limited ways of seeing, if photographs shrink it, if perspective flattens it, if comparisons mislead us, then how much of cosmic reality do we misunderstand simply because we rely on images? How much does the universe change when we remove filters, calibrations, distortions, when we try to see it not as a picture, but as a place? Well, perhaps now is the right moment to confront that illusion, to step into the quiet truth that reality itself is larger, richer, more complex than any image can convey, and to explore how our own tools, our own eyes, and our own minds often shrink the universe into something far smaller than it truly is. And so, as we drift outward from the immense architecture of galaxies and the quiet comparisons that place Andromeda within the cosmic hierarchy, another realization begins to surface, softly at first, like a question whispered in a vast room. You see, so much of what we think we know about the universe comes not from direct experience, but from images, photographs, renderings, charts, little windows through which we try to glimpse an immensity that cares nothing for the frames we put around it. And well, these images, for all their beauty and precision, are also distortions. Not lies, no, but translations, simplifications, approximations created by instruments that must compress an unthinkable scale into something our small eyes and small minds can hold. And the first distortion is size. When we look at a picture of Andromeda on a screen, it might measure a few centimeters across. We see its spiral arms contained neatly inside a rectangle. Our brain, always eager to simplify, accepts this framing as truth. It imagines the galaxy as something we might cup in our hands if only we could reach out far enough. But to fit an entire galaxy, 200,000 light-years wide, into a tiny image requires compression so extreme that everything meaningful about its scale is flattened into insignificance. In the real universe, the space between stars is so vast that a human lifetime, multiplied 1,000,000 times, could not traverse it. Yet in a photograph, those stars sit almost shoulder to shoulder, crowded into tight glowing lines. This compression isn't merely a technical artifact, it shapes our intuition. We begin to imagine the universe as smaller, more navigable, more familiar than it is. We look at Andromeda beside the Milky Way in diagrams, and they appear like two siblings sitting side by side. But in truth, they are separated by a gulf so vast that even light, that tireless traveler, takes millions of years to cross it. The images trick us. They offer convenience at the cost of immensity. And then, There is color, another quiet deception. Many of the most iconic images of Andromeda or other galaxies are not photographs in the traditional sense. They are composites, crafted from data collected in different wavelengths of light: infrared, ultraviolet, X-ray, radio. Human eyes cannot see these wavelengths at all, so scientists assign colors, sometimes symbolic, sometimes artistic, so that the structures hidden within the data become visible. The glowing blues and purples, the fiery reds, the shimmering golds, they are interpretations. They reveal real physics, but not real color. If we could drift near Andromeda and look at it with our own eyes, it would appear far paler, softer, more diffuse than the images suggest. The vibrant blues that highlight star-forming regions would be faint whispers of color. The warm golden core would appear more like a subtle haze. The galaxy's beauty would not be diminished, but it would be different. Quieter, more delicate, more honest. Images exaggerate contrast and brightness to pull detail from darkness. They are like paintings in which the artist heightens the colors to make the story easier to see. And well, even the shape of galaxies can be misleading in pictures. We often forget that these are not flat disks floating in space, but three-dimensional structures with depth, thickness, and complex layering. When we look at Andromeda in a photograph, the arms appear orderly, symmetrical, almost artistic, but reality is messy. The disk is warped, the halo is lumpy. Dust clouds create shadows that distort apparent shapes. Photographs flatten this complexity into a two-dimensional impression, like pressing a leaf under glass. The form is preserved, but the life of it, the volume, the contour, the motion, is lost. Another distortion comes from the way telescopes collect light. Long exposure photography allows faint objects to accumulate brightness over minutes or hours. A camera can gather more light than the human eye ever could. And so the Andromeda we see in images is not the Andromeda we would see if we traveled to its outskirts. The camera reveals detail the universe does not offer freely. Without such tools, the galaxy would look ghostly, barely there, a whisper of brightness spread across a wide region of sky. Our instruments pull it into clarity, but in doing so, they also create an illusion of accessibility. And you see, this subtle misunderstanding affects more than our perception of galaxies. It shapes how we imagine the universe itself. When we scroll through images on a screen, nebulae burning with impossible color, galaxies arranged like carefully curated artwork, we begin to think of the cosmos as beautiful, but manageable. Yet the real cosmos is stranger, darker, emptier, and more enormous than any image can convey. The pictures we adore are glimpses translated into human terms, crafted to fit our perception. Even distance becomes distorted in images. Two galaxies may appear side by side in a photograph, but one might be millions of light years behind the other. A single bright star in the foreground can be hundreds of times closer than the galaxy it overlaps visually. Photographs collapse depth. They turn layers of cosmic history into a single, unified plane. We lose the sense that every pixel of light might have traveled for vastly different spans of time. Light arriving from Andromeda tonight began its journey when early humans walked the Earth. Light from more distant galaxies began traveling long before the Milky Way had even formed. Yet in images, all that ancient history is condensed into a single moment, a single frame. And well, this brings us to an even deeper distortion, the illusion of stillness. Photographs freeze galaxies in time. They show spirals in perfect symmetry, star clusters forming elegant arcs, dust lanes carved like brushstrokes. But galaxies are not still. They writhe, they twist, they stretch under the influence of gravity and dark matter. Spiral arms rotate, stars drift, gas collapses. Entire structures warp and twist over millions of years. Images remove the motion and with it, the sense of galaxies as evolving entities. They give us the universe as a painting when the truth is that the universe is a dance. And yet, despite all these distortions, images are indispensable. They are tools, translations. They grant us access to realities we could never experience directly. Without them, Andromeda would remain a faint blur. Without them, we would have no sense of the vast stellar nurseries hidden within its arms, or the great arcs of dust sculpting its disk, or the streams of stars pulled from shattered satellites. Images give us knowledge, but not perspective. The perspective must be earned by understanding what the images cannot show. Perhaps the most humbling part of this entire realization is that our minds cling to images even when we know they mislead us. That is simply how human cognition works. We think in pictures. We imagine in shapes and colors. And so the universe becomes what our instruments show us, even when our instruments must distort the truth to make it visible. But there is a quiet beauty in this too. The fact that we must translate the cosmos into images reminds us how foreign it is, how far beyond our evolutionary comprehension. Andromeda is not a photograph. It is a place, vast, turbulent, full of motion and structure and silence. Our pictures are invitations, not answers. And as we contemplate the gap between what the universe is and how we perceive it, another thought rises gently into view. If images shrink, simplify, and stylize the cosmos, then what do they make of our own place within it? How small are we truly when seen against the backdrop of such immensity? How does the scale of Andromeda, the Milky Way, and the entire cosmic landscape reshape our sense of identity, our understanding of what it means to exist at all? Well, perhaps now is the moment to turn inward again, to consider not just the galaxy itself, but the fragile, tiny human perspective that tries to grasp it, to explore how the enormity of Andromeda reflects back onto us, revealing both our insignificance and our astonishing ability to wonder. And so, as we sit with the quiet truth that our images shrink the universe into something we can look at rather than something we can truly inhabit, another realization rises slowly into view, like dawn emerging behind a mountain ridge. You see, once we understand how much our perception softens the cosmos, the next natural step is to turn inward and ask, where in all this immensity do we stand? And well, that question is not a scientific one alone. It is a human one, a philosophical one, a question that seems to echo back from the stars themselves. When we place Earth against the scale of Andromeda, something curious happens. The planet that feels so expansive beneath our feet, with oceans that seem endless and horizons that seem unreachable, becomes smaller than a grain of dust floating in a cathedral of starlight. The mountains, the continents, the whole of human civilization, all the stories, empires, dreams, and sorrows fit into a space so tiny that Andromeda would not notice, even if it drifted right through it. And that realization can feel unsettling at first. We are creatures who build our lives from the closeness of familiar things. A room, a city, a country. That is the scale of our comfort. But the universe invites us to step beyond that comfort. Gently, slowly, like someone opening the curtains to a sky we did not know was there. Think of a single star in Andromeda. Just one. It may be enormous, burning with the brightness of 1,000 suns, or it may be small and dim, glowing faintly at the edge of the galaxy's spiral arm. Now imagine Earth beside that star, not orbiting it, just placed next to it for scale. Earth would not register. It would be a mathematical inconvenience, a point, a near nothing. And then consider that Andromeda contains perhaps 1 trillion such stars. 1 trillion small infinities stacked upon each other in silent harmony. Our entire world, fragile and precious, becomes smaller than the smallest breath of dust in a storm stretching 200,000 light-years wide. And well, the scale continues to expand. A cluster of stars dwarfs a single star. A galaxy dwarfs a cluster. A cluster of galaxies dwarfs a galaxy. And between those clusters lie voids so immense, so staggeringly empty, that one could place Andromeda inside them and still have room to spare. The cosmic architecture grows and grows until human measure ceases to have meaning. We are left with metaphors, with images, with questions. We are left with the simple fact that we are small, wonderfully, achingly small. But, and this is the thing, the universe does not diminish us by its vastness. It does the opposite. You see, smallness in the cosmic sense is not the same as insignificance. A grain of sand on a beach is small, yes, but it carries the whole story of the earth within it. A single drop of water reflects the entire sky, and a single conscious mind resting on a small blue world at the edge of a modest galaxy can look outward and imagine all of this. What other speck of matter, drifting through the darkness, can say the same? The fact that we are small means that everything we do carries weight. Every thought, every kindness, every fleeting moment of awareness is rare, astonishingly rare. In a universe where most matter will never think, never feel, never wonder, consciousness becomes a kind of treasure. Life becomes a miracle not because it defies physics, but because physics produces so much emptiness by comparison. And perhaps that is why galaxies like Andromeda inspire not despair but reverence. They remind us that existence is vast beyond comprehension, yet somehow, improbably, we are here to witness it. We are here to ask questions. We are here to marvel. You know, maybe that is the quiet gift of the cosmos. It teaches us perspective, not to make us feel lesser, but to help us recognize the extraordinary nature of simply being. We are a species that can look across millions of light years, understand the motion of galaxies, trace the life cycles of stars, and still feel a sense of wonder deep in the heart. That duality, knowledge and awe, makes us something unique in a universe that is otherwise silent. When we gaze at Andromeda, we are looking at a structure older than every civilization, every language, every memory on Earth. Its light began its journey before our species existed, before any of our ancestors learned to stand upright. And yet here we are, in the quiet of night, letting that ancient light brush gently against our eyes. It feels almost like time itself leaning in to whisper a story. And Andromeda, in that moment, becomes not merely a galaxy, but a mirror. It shows us the immensity of the universe, yes, but it also shows us the tenderness of being alive within it. It tells us that fragility is not a flaw, it is a feature. Fragility is what allows life to emerge, to feel, to question, to love. The universe is vast, but it is from smallness that meaning grows. So perhaps the question is not why are we so small, but how extraordinary it is that something so small can see so far, that we can stretch our imagination until it spans the distance between galaxies, that we can look at a faint blur in the sky and unravel its story, that we can contemplate our place in a map so large it challenges the boundaries of thought. And well, perhaps this gentle contemplation prepares us for the final step of our journey, a moment when we turn not only to the galaxy or the cosmos, but to the question that lingers quietly within every human being who has ever looked up at the night sky and wondered where they truly stand. Because now, after unfolding the vastness of Andromeda, after walking through size and distance and gravity and starlight and perception, perhaps it is time to ask, where are you on the map of the universe? And how does knowing that change the way you see the world beneath your feet? And so, as that quiet question settles, where are you on the map of the universe? We find ourselves standing on a kind of threshold. You see, this is the moment when the story of Andromeda turns gently inward, no longer pointing only toward the stars themselves, but toward the way those stars reshape our understanding of existence. And well, if the previous chapters showed us how vast the galaxy is, how faint our senses are, how images compress reality into something manageable, then this next part asks something softer, something more human. How does knowing all of this change the way you see yourself? Because once you've walked through the scale of Andromeda, its spiraling arms, its trillion stars, its satellites and streams and invisible halo, something shifts inside you. The world you carry in your mind becomes larger, deeper, more intricate. The familiar edges of your daily life soften, and the boundaries of your imagination stretch until they meet the quiet, ancient light drifting toward Earth from 2.5 million light years away. And when that happens, you begin to sense something profound. The universe is not small enough to fit into our understanding, and yet we are large enough to try. And that effort, this striving to comprehend a cosmos that continually outpaces us, is part of what makes being human so extraordinary. Our species emerged on a tiny planet orbiting an ordinary star, in a galaxy that is itself merely one among billions. Nothing about our beginnings suggested that we would one day contemplate the fates of galaxies, trace the paths of stars across cosmic distances, or ponder our own position in a map that stretches beyond imagination. And yet here we are, in the quiet, hours of a night in distant 2025, asking questions that the universe has been waiting billions of years to be asked. It is strange, isn't it? On cosmic scales, humanity is almost non-existent. If you placed Earth beside a single star, it would vanish into invisibility. If you placed the entire solar system beside Andromeda, it would shrink to a speck. If you placed the Milky Way beside certain supergiant galaxies, even it would become a footnote. And yet, inside that speck, inside that nearly invisible oasis of matter and chemistry, thought emerged. Curiosity emerged. The ability to marvel emerged. And well, that is the quiet irony. The universe is made mostly of things that will never notice their own existence. Stars burn without reflection. Galaxies collide without meaning. Entire clusters drift through darkness without ever asking why they exist. But here, in a momentary flicker on a fragile planet, consciousness appeared. Awareness appeared. The ability to love, to grieve, to hope, to imagine. These are cosmic rarities. They are as unlikely as a flame rising from deep water, and yet they happened. So perhaps our smallness is not a flaw, but a feature. Perhaps meaning arises not despite our scale, but because of it. If we were giants drifting among the galaxies, maybe the universe would feel less miraculous. But because we stand on the edge of something overwhelmingly vast, every glimpse becomes precious, every question becomes profound. The night sky is not a backdrop, it is a reminder that we are both impossibly tiny and impossibly fortunate. You see, when we understand Andromeda's true size, its true distance, its true mass, something shifts in the way we perceive our daily lives. Suddenly, the small frustrations of being human, the worries, the deadlines, the fleeting conflicts, soften just a little. Not because they stop mattering, but because we see them in a larger context. We remember that we are alive in a universe where life is rare. We remember that consciousness itself may be a momentary miracle. And we remember that this world, this little blue fragment of stardust, is the only place we know where matter has learned to wonder. And perhaps that is the secret of scale. The bigger the universe becomes, the more significance we can find in the small spaces we inhabit. When you know that galaxies collide over billions of years, that stars live and die in violent beauty, that light takes ages to cross the void, then the quiet moments of human life, breathing, listening, holding someone's hand, feel achingly fragile and deeply meaningful. They become constellations of their own. And well, another truth emerges from this perspective. The universe is not indifferent to us because of its size. It is simply vast. Indifference assumes intention, but the cosmos has no intention at all. It simply is. And into that neutral, ancient expanse, we bring meaning. We bring stories. We bring the ability to recognize beauty in things that are unimaginably far away. And that recognition, that spark of understanding, is something no galaxy possesses on its own. So when you stand beneath the night sky and see Andromeda as a faint blur, or when you look at an image that exaggerates its brightness and color, remember that both experiences reveal different truths. One shows you the limitations of your senses. The other shows you the reach of your imagination. And together, they tell you something about what it means to be human, to exist at the intersection of what you can perceive and what you can imagine. And perhaps that is why, even after all the science is laid out, even after all the facts and distances and masses and scales have been explored, something still stirs within us when we contemplate Andromeda. It is not just a galaxy. It is a reminder that we live in a universe old enough, large enough, and mysterious enough to humble us, and gentle enough to let us ask questions anyway. And this brings us to a deeper reflection, one that lingers quietly in the background of all cosmic contemplation. If we are so small, and if the universe is so large, what responsibility do we carry by simply being aware of it? What does it mean to be a species capable of shaping its own world, even as it floats unnoticed through the vast ocean of the cosmos? Well, perhaps that question leads us naturally to the next step in our journey, to think not only about Andromeda, not only about the universe, but about the fragile little world where all of these questions arise, to consider the relationship between cosmic scale and human responsibility, and to ask what it means to care for the only home consciousness has ever known. And so, as we stand at this quiet crossroads between cosmic immensity and human responsibility, a softer truth begins to unfold, one that feels less like an answer and more like an invitation. You see, after wandering through the spiraling arms of Andromeda, after drifting across the dark oceans between galaxies, after peering into halos of invisible matter and contemplating the fragile gift of consciousness, we arrive back here, on this small world beneath our feet. And well, it becomes impossible not to see Earth differently. Not smaller, strangely enough, but more precious, more deliberate, as though the universe spent billions of years arranging the conditions for one simple miracle, the chance to be aware of itself. Because when you understand the scale of Andromeda, the age of its light, the slow dance it performs with the Milky Way, something shifts in the human heart. The world stops feeling like the default stage of existence and begins to feel like an oasis in a wilderness so vast it defies language. The oceans become rarer, the forests become rarer, even the air becomes something like a gift. And perhaps that awareness is the beginning of responsibility, not imposed by the universe, but arising from the simple fact that we are the only thing we know of that can feel reverence for it. Imagine, for a moment, a map of the universe, not the flattened diagrams we see in textbooks, but a living, breathing map stretching across space and time. On that map, Andromeda sits like a great lantern drifting quietly in the cosmic night. The Milky Way drifts beside it, bound by invisible tides. Clusters and filaments weave their ancient patterns around them. And somewhere, tucked into the outer arm of our own galaxy, barely a glimmer, lies Earth. A pixel within a pixel within a pixel. And yet, on this pixel, thoughts bloom. Questions arise, stories form. A species looks upward and, without knowing why, feels moved. It is tempting when confronted with this vastness to feel insignificant. But insignificance is not the only interpretation. Perhaps the more astonishing truth is that meaning emerges precisely because of our smallness. A candle in a cavern does not lose importance because the cavern is large. It becomes more miraculous because it exists at all. And in that sense, humanity becomes a kind of illumination, a fragile glow in a universe that is otherwise silent. And you see, Andromeda teaches us something else, something subtle. It shows us that scale is not a measure of value. A galaxy is vast, but it does not ponder its own existence. A star burns fiercely, but it does not love. A nebula glows, but it does not wonder why. We, however, do. We carry sunsets in our memories, fears in our chests, hope in our hands. We build telescopes and send questions into the dark. We map the movement of galaxies we will never reach. We tell stories about the stars. And in doing so, we bring meaning to a universe that would otherwise have none. So perhaps the true lesson of Andromeda is not that we are small, but that smallness is the very condition that allows wonder to exist. If we were as large as galaxies, perhaps the beauty of galaxies would vanish from our experience entirely. If we lived for billions of years, perhaps time would lose its sweetness. If the universe were constructed at human scale, perhaps curiosity would fade. Our fragility, our brevity, our limitations, they are not weaknesses. They are what make awe possible. And well, once you realize that, the world shifts again. You begin to see Earth not as a random rock in space, but as a singular cradle of consciousness, a place where the universe looks inward and learns to understand itself. You begin to see that every forest, every river, every breath of wind plays some small role in keeping that consciousness alive. And you begin to feel perhaps a gentle responsibility toward it. Not because the universe demands it, but because awareness itself invites gratitude. And there is something quietly beautiful about living in a time, this moment in distant 2025, when human beings can look beyond their own world and glimpse the structure of galaxies. We are the first species on Earth to know that Andromeda exists, to understand that it is approaching, to imagine what will become of our galaxy in billions of years. We are the first to map the cosmic web, to trace our lineage to stardust, to realize that the atoms in our bodies were forged in the hearts of ancient suns. And that knowledge changes us. It softens us. It humbles us. It opens a space inside us where awe can live. But this awe is not passive. It invites action. It invites care. When you understand how unlikely, how delicate, how improbable consciousness is, you begin to treat the world that sustains it with more tenderness. You begin to cherish the very things that once seemed ordinary: the breath in your lungs, the warmth of sunlight, the company of others, the strange miracle of simply being alive. Because now you know that galaxies drift for billions of years without ever producing a mind capable of wonder. And perhaps that is the final revelation Andromeda offers. In a universe governed by vast, indifferent forces, meaning is something we create. It does not come from the galaxies. It comes from the gaze that contemplates them. It comes from the fragile spark within us that dares to ask questions, that dares to care, that dares to dream. So when you next look up at the faint blur of Andromeda in the night sky, remember that you are witnessing something older than all of human history. Remember that the light touching your eyes tonight began its journey long before your species existed. And yet, here you are, able to hold that light in your awareness, able to let it change you, able to weave it into the story of your own existence. That, in itself, is extraordinary. And well, perhaps this gentle wonder leads us naturally to one more thought, one more quiet doorway opening into the next journey. If understanding Andromeda helps us see the value of our tiny place in the universe, then what might we discover by turning that gaze back toward ourselves? What might we learn about humanity, about Earth, about the fragile ecosystems that sustain consciousness? When we look at them with the same awe we reserve for galaxies? Perhaps now is the moment to follow that thread, to shift from the cosmic to the intimate, and to explore what it truly means to live on a world that, against all odds, has learned to wonder at the stars.